This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.7 on projectile motion, question number 8. It says, in a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 3.2 meters away. After a running start, he leaps at an angle of 14 degrees with respect to the flat roof while traveling at a speed of 5.8 meters per second. The acceleration of gravity is 9.81 meters per second squared. To determine if he will make it to the other roof, which is 2.1 meters shorter than the building from which he jumps, find his vertical displacement upon reaching the front edge of the lower building with respect to the taller building, answer in units of meters. Okay, I think a picture would be in order here. I've got one building. I've got another building. I know that this displacement here between the two buildings is 3.2 meters. I know that this building is a little bit shorter than this building, so that if this were this dotted line here, that this distance here is going to be 2.1 meters. So what I'm interested in is when he jumps up and comes down, he could wind up here, he could wind up here in the corner, he could wind up here below. I'm trying to figure out what his displacement will be by the time he reaches this building. So what I'm looking for is, let's just assume he's above, and I'm looking for this height right here, this vertical. So what do I know? I've got x world, I've got y world. In the x world, what I see is 3.2 meters. I know my acceleration is 0. I know my displacement is going to be 3.2 meters. In the y world, I know that my acceleration is g is negative 9.81 meters per second squared. I don't know my displacement. I'm not going to use this 2.1 because that would be ideal, but I don't know if he's going to wind up above or below that. So really y is what I'm looking for. I don't know my time, but I can get my initial velocity because I have this 14 degrees and 5.8 meters per second. So that's going to be a 5.8 meters per second, and that's going to be at an angle of 14 degrees. So I can get my initial velocity in the y direction and my initial velocity in the x direction. So since the y is opposite to 14, my initial velocity in the y direction is going to be my velocity here, this 5.8, times the sine of 14, because SOHCAHTOA tells me that its opposite has to do with the sine. So 8 times sine of 14 is my initial velocity in the y world. My overall velocity in the x world
is going to be the cosine. It's going to have to do with the cosine because this is adjacent. So it's going to be 5.8 cosine 14 degrees. So here will give me my x velocity, here's my y velocity. What I'm looking for is my displacement. I've got an acceleration, an initial velocity, a displacement. If only I had a time, I could solve this. And where I'm going to get time is it's going to come from the x world because I have a distance and a velocity. So I know that since velocity is distance over time, that time is going to be my displacement over my velocity. I know my displacement is how far these buildings are. So when he's traveled 3.2 meters, where is he? So that's going to be 3.2 meters divided by 5.8 cosine 14. That's going to give me my time. And that time will flow right over here and give me this time. Now I want to know my height. When he starts with this velocity and he accelerates this way, and that's his time, so now I can do that my height, my displacement vertically, is my initial velocity times time plus 1/2 my acceleration times time squared. So my height is going to be, my initial velocity is 5.8 sine 14 times my time, which is just t at this point, it's whatever you get here, plus 1/2 of negative 9.8 times that same time squared. And that will give you your displacement. And the way this is written, it says find his vertical displacement. It is asking for a displacement. So this should be a negative number because it's a displacement. So I should get a negative, and that should be my answer.